I'm going to model a mass on a spring. The mass of 0.1 kg. This is the mass of the ball. The ball is compressing a spring which is initially of length 2 meter to 1 meter. So the initial position of the spring is 0, 1, 0. This L at is the unit vector. K equals to 8 is the stiffness. Initially it is at rest, so the initial momentum is 0, 0, 0. M is the mass, g is the acceleration due to gravity, and we are taking dt equals to 0.05. that means for each iteration change in time will be 0.05. now spring equals this code generates the model for a spring, and the position of the spring is axis of the spring is 0, 1, 0, which is the stretched length, which is the stretched length. As the ball is on the top of the spring, the position of the sphere will also be similar to this one. Now this one is for the graph, and this is the base of the spring mass model. Now we have to find the final position after 1 minute, final position of the ball after 1 minute when the hand is released. So 1 second, actually sorry, that's 1 second. Sorry, t is less than or equals to 1, t equals to t plus dt, f equals to m times g, m times g. Y, this gives the magnitude of L vector. F yes equals to force due to spring is negative k times stretch, that is L mag, minus initial length, that is L0, times L hat. Now F net force is F net, T net equals to F e plus F yes. Final momentum Pf is given by Pf equals to Pi plus F net into multiply dt. For next iteration, the final momentum here will be the initial momentum, so Pi equals to Pf b Vg. As the ball is initially at rest, the final velocity, the average velocity is equals to final velocity, which will be given by Pf over m. Now the final position for first iteration is back plus b avg times dt. Now we have to update the axis, that will be equals to rf, and similarly we have to update the position of the ball, which will be equals to ref as well, equals to ref. Now printing ref will give us the value of the position of the ball after 1 second. After 1 second, so for plotting to see the graph, graph dot plot, will plot time on the x-axis and position, that is y component of RR vector, that is y in the y-axis. So PL plot. Now grab the t comma r dot y. Sorry, mass on the spring, so for submission edit 0 line 21 yellow mag previous yal, sorry, it's yal vector times now. So this is our model. This program, run this program. Actually we have to decrease, we have not kept a rate here, so rate, so let's keep it 10, 1010. Now run program. Now here it is. So the position of the ball after 1 second is 2.76, 2.76, and here is the graph for each time, and it is here in the x-axis the time is there, and for the position the position is given by the y-axis. So let's run again. So this is the model for the problem.